Hey, what's up everyone? I am Gabriel Barbosa, but you can call me Gabriel or just Gabe. I make videos about game development here in Brazil, in Portuguese, and this is my first attempt at making a video in English. I am studying English, and this is a way for me to practice my speaking. In this video, I want to recreate a tutorial by a famous creator here in Brazil. He has a mega famous course called Donkey Code. It's one of the best game development courses we have here. And as English is my second language, it's very possible that I will say something funny or mistranslated in this video. Okay, let's begin. I have already created a new 2D project. I am using Unity 2022. I already have sprites that I'm going to use. You can use any other image. If you don't know how to import image, simply drag the file into the project in Unity. Simple as that. Unity is super easy to use. I am using a ground, a bucket for the player, and an apple for our collectible. I am going to put the ground first. Just drag to hierarchy to define our floor for the game. And I am going to put the bucket too. I have 3 different buckets. I'm going to use this one. Let's rename it to just bucket. The bucket is gonna be the player. We are going to change the aspect ratio of the game to be played vertically. I created this aspect ratio here. You can define the aspect ratio or a fixed resolution. You can create a new one clicking in this icon here. We are going to define the ground as tiled in the draw mode. And as I increase it, let's focus on ground. As I increase, the sprite will repeat as if it were several tiles. I will position at the bottom, and I'm going to reposition the bucket too. And now we are going to program the bucket. Let's create a folder. Right click on the assets, create folder, and inside this scripts folder, right click, create C# script, and I am going to call it bucket. One very important thing in Unity, for the script to be used as a component, the file name must be exactly the same as the class name. When you create and name it, Unity already does this. So you can see here the file name is bucket and the class is bucket too. But if you change the name later, you need to change it in both places. Let's open the script. Okay, we need to capture the player's horizontal inputs. We are going to use Unity's default input system. It's easier for a simple tutorial. Unity already has a horizontal input registered. We want to capture the input at all times, so we are going to do this check inside update. Update is a Unity method that is called every game frame. So if a game is running at 60 frames per second, it will be executed 60 times a second. Let's define a local variable to store the horizontal value. I won't go into programming details. Maybe I can do something covering the basics of programming later in another video. It will be of type float. The name is going to be horizontal, and it's going to be equal to input dot get axis. I need to write the name horizontal in quotes. This autocomplete is from GitHub Copilot. That's my programming secret. So okay, what this line does is the following. When we press the A or left arrow key, the value of horizontal becomes -1. If I don't press anything, it becomes 0. And if I press to the right, it becomes 1. With getAxis, there is an acceleration. The value goes from 0 to 1, from 1 to 0, etc. at a speed. We can set this in the project settings. If you don't want this acceleration, you can use getAxisRaw, so it only works with the integer values. Now that we've captured the input, let's use it to change the player's position. We are going to use the translate method of the transform. We can access the transform of the object to which this script is attached by simply typing transform. Here I need to pass which direction I want to move my object. We are going to use vector3.right, which will move it horizontally and is just multiplied by the value of horizontal, which will move it left or right. If I don't press anything, it multiplies by 0 and stays still. We are also going to multiply by delta time, which is the interval between frames. This way it becomes independent of the frame rate and becomes relative to time. And we are going to multiply by a speed. We are going to set this speed as a public variable that can be accessed by the Unity editor and by other classes. We also need to define the object's limit, as it cannot leave the screen. For this, we are going to create a public variable to define this in Unity, because I don't know what value I'm going to use. I'm going to call it xLimit. We are going to do a very simple check. If the position on x horizontally is greater than xLimit, we set the object's position to the limit position. The same for the left, but we are going to check if it's less than the negative value of xLimit. Alright, in this very simple way, we created the script for our player. Let's save it and test it in Unity. Let's go back to Unity. I need to attach the script to the bucket. I'm going to select the bucket. Just drag the script up to it. And let's see the limit horizontally. I'm going to take the bucket. Okay, I think maybe 3.3 for the x limit. And let's test it. Alright, very simple, very good. Always remember to save the scene. Now let's create the fruit that will be spawned. Let's drag the apple into our scene. Let's rename it to apple. I'm going to put at the top. I'm going to make it fall automatically using physics. This way we don't need to create a script to do that. Let's add a component responsible for physical interactions, which is rigid body 2D. Since I'm using 2D physics, I'm going to use rigid body 2D. I'm going to leave it as it is and let's test it. Okay, it's perfect for me. You can increase or decrease gravity scale to fall slower or to fall faster. I'm going to use the full gravity scale. Both the apple and the bucket will need collision. We are going to use everything in trigger. I don't want solid collision. Let's put a circle collider 2D on the apple. I'm going to reduce the size a bit. You can click in this button. Check the is trigger option and a box collider 2D on the bucket. Okay, it's perfect. Let's save the apple as a prefab. A prefab is nothing more than a model of an object that can be reused in the game. I'm going to create a folder called prefabs and simply drag the apple into this folder. There is a lot of drag and drop in Unity. Now I can delete the apple from the game scene. And let's create an object that will spawn the apples. Create an empty object. I am calling apple spawner. Its position will not affect anything, but I'm going to reset it. Let's create another script and call it apple spawner. And let's open it. We need to know the object that will be spawned. In this case, the apple prefab. We'll be creating copies of it, and the position in Y will be fixed, and in X random. So let's create two variables, one to store the apple prefab and another to set the limit in the horizontal. I'm going to create a function to spawn the fruits. This is a function that I am creating, so I need to call it at a certain point. Let's use a variable to define the X position. I'm going to use a function that draws a random name, and for the function, I need to pass a minimum value and a maximum value. And the return is for me a value between those two numbers. I'm going to define the position using the returned value. The position in Y, it's going to be 10, to be at the top of the screen, outside screen, and the position in Z can be 0. And use the instantiate function to create a clone of the apple. For the instantiate function, I need to pass the object I want to clone, and a position and a rotation. There are other ways to execute this function as well. And I'm going to use invoke so that this function is called again after a random amount of time. So I can use invoke and call this function. And I am going to use the random range function. And I'm going to call it through invoke by start as well. For invoke, I need to pass the name of the function between quotes and also the interval. And that's it. Let's save it. Return to unit. Let's add the component to the apple spawner. We need to define the apple prefab. Let's drag the apple prefab into the field. And I'm going to see the X limit. I'm going to use 3.5. And last test. So okay, it's working in random positions and at random time. Okay. And to finish, let's add the scoring. First, we need a text to display the score. Let's create a new object. UI, legacy, text. We'll just use a simple text. I'm going to double click canvas and position the text at the upper left corner. I will change the text that is written to get a better idea. We can change the size and the color, the font style. Okay, it's good for me. Now let's modify the player's script to know when it collided with something. If it collided with the apple, we'll add a point. We are going to identify the collision by the tag. It won't make a difference in this project because we don't have other objects to differentiate during the collision, but we'll do it this way because it's more common in other projects. Select any object, click on the tag name, add a tag, and I'll put the name of Apple. Save. Now select the Apple prefab and change the tag to Apple. Let's go back to the bucket script. I think it's easier to scroll through the bucket. To be able to access the text, we need to use the Unity UI library. So let's add it. We are going to create a reference variable to the text. And a variable to keep the score. The score will be of the integer type. We'll use the onTriggerEnter2D function to know when the bucket collided with the apple. This function will be called every time the bucket collides with any object. When it collides, we'll check if the tag of the object it collided with is in the apple tag. We can find out which object it collided with through the collision parameter. So let's check. I'm going to use compare tag. We don't need to use game object. Compare tag. And I'm going to pass the name of the tag in quotes. Every time we use a value of a string, we need to write the name in quotes. If the object is an apple, we are going to destroy the object, add 1 point, and change the point's text. Let's save, go back to Unit. Let's select the bucket, drag the points text to the points text field, and let's test. It's very fast. I'm going to change the position that the apple is going to be spawned. I'm going to use 5.5. Let's change in the script. Okay. Now it's easier. Okay, alright. There are many more things that still need to be done, but I wanted to do something simple for this English tutorial. I hope you like it. We'll see you next time. Thanks and bye.